Hello, welcome to Studio X's Intro to Unity workshop. Today we'll go over what Unity is, some key concepts, hands-on time, some resources, and next steps for progressing with Unity. First, I'd like to just go over this slide we have in all of our Studio X workshops. It's just to reiterate that we are all learners together, and that no matter what level you are welcome and you are able to follow along with this workshop. So, Unity, what is it and why do we use it? So, Unity is a real-time game engine. And what this means is that Unity streamlines game development by bringing together many aspects of interactive design, such as user interface, lighting, animation, coding, and it brings them all into one package and does it all while responding to user input instantly. The user interface abstracts away a lot of the complexity of game development, making it easier to jump in. Unity was first released in 2005 and has its roots in game design, but it's now a framework for all kinds of projects, such as movies, healthcare, architecture, manufacturing, and more. 50% of all games deployed to Windows, macOS, iPhone, and Android are made with Unity, and 60% of all XR experiences are made using Unity, which is why we at Studio X place such an importance on using Unity. So here are some examples of experiences made using Unity. You may know some of these. In the bottom left, it's Beat Saber, and that's one of the most popular VR games of all time. In the top right, we have Pokemon Go, which is one of the most popular AR games of all time. In the bottom right, we have Equal Reality, which is a VR diversity and inclusion training application. And in the top left, we have Also VR, which is a application designed to train for surgical and emergency preparedness. So all of these experiences were made using Unity. So that's why we use it. So here's what you'll see when you load a project in Unity, and highlighted here are the important windows you'll be interacting with. First off, we have the project window on the bottom. This window holds all the files in your project. This can range from audio to images to 3D models. So any sort of file will be here in the project window, and those items are referred to as assets. And you can actually see that the main folder in the project window is called assets. Next up is the scene view, which is right in the middle here. And it shows you the current 3D space that you are working with. So this will allow you to navigate around your 3D space and manipulate objects, move them, rotate them, etc. And the toolbar on the top is a bit different in more modern versions of Unity, but this is where you can play test your games, switch from game and scene view, and things like that. And one of the most important ones we have is the hierarchy window. And this shows what game objects are currently in the 3D space or are seen. So anything currently in your scene will be listed in the hierarchy window. So you use both sort of in tandem. The inspector window all the way on the right here allows you to interact with the various components that might be attached to any of your game objects. So this will allow you to change the behavior of game objects and also directly manipulate them. And one very important detail I'm going to go over before we jump into Unity is the difference between scene view and game view. So scene view is meant for behind the scenes work. It's the creator space, the sandbox where you interact with the 3D space. And game view is what the player will see. And also the game view is not interactable unless you're play testing your experience. So game view is very useful for knowing what your game will look like for whoever is playing your experience. But for the majority of this workshop, we'll be working in the scene view. So next we're going to talk about game objects, the actual things taking up the 3D space. And remember that game objects are found in the hierarchy window. So a game object, as I've said before, is any object in the scene, and therefore also in the hierarchy window. Game objects can be characters, props, scenery, lights, and more. And you might be wondering why the hierarchy window is called the hierarchy window instead of something like the game object window. And this is because game objects can have a hierarchical parent-child relationship. And an object can be the parent or child of another one. This is useful because let's say you had a car object that had children objects being its wheels and the car door and other components of a car. Those extra children objects are subject to the same position, rotation, and scale of the parent. So when you want to move the whole car, you only have to move the one parent object instead of individually moving each object to match it. You can also create an empty game object, and these are really useful because you can use them as containers to organize your game objects, kind of like a folder in, File Explorer or other file management applications. And so this is how Studio X's projects are organized. We like to create empty game objects that contain, for example, environment, game objects, or props, or things like that. So game objects are made up of components, and components are located in the inspector window. And components are what make game objects functional and what define their behavior. And there are many different types of components, ranging from audio to physics and much, much more. And some of the most important components, are things relating to physics, 3D rendering, textures, and those sorts of components are already pre-written and are built right into Unity. You don't have to write any code. They're just right there for you to use. However, if there is some functionality you would like that is not already implemented, you can always create your own components through scripting with Unity's scripting language, C#. So without all of that out of the way, we're about to get started in Unity itself. However, I'd like to briefly mention that Unity is best used as a two-handed application. And so for righties, I'd highly recommend keeping your left hand on WASD and your right hand on the mouse. And for lefties, you can use the arrow keys with your right hand instead, if that's more comfortable for you. So now go ahead and open Unity. If you're having some trouble setting up Unity, you can always view our Unity setup tutorial on YouTube. Otherwise, let's jump right in. Except for one little reminder is to always be saving your project. You'll never know when your computer might lose battery and die if you have a laptop, or you never know when Unity might decide to crash on you. So it's always a good idea to just save your project whenever you make changes, so that they don't get lost. All right, so once you get into the Unity editor, I want you to start moving around the scene and try to look for the 3 ground boys in the scene view. This is practice for you, so you can get used to the controls of Unity. You can move around by holding right-click and pressing the WASD keys. And alternatively, you can also use the arrow keys to move. However, when you're using the arrow keys, you don't need to hold down right-click. To rotate your view, you can hold right-click and drag your mouse. To move up and down, you can right-click, hold right-click, and press E for moving up and Q for moving down. And you can also use the scroll wheel on your mouse to zoom in and out. So let's head into Unity and get started. So holding right-click will give you this different mouse icon, and when you hold right-click, you can then use WASD to move. So W for forward, S for back, A for left, and D for right. And doing this, we can find our first ground boy, who is right here. But there are 2 more we need to find. So we're going to move around the map, just be flying around. And we will find our next ground boy right here. So there's number 2. And then we have to find number 3. So where haven't we looked yet? Well, here's Rochester. And if we hold E, or hold right-click and press E, we'll go up. And if we press Q, we'll go down. So we can do this to quickly get up here, and we'll find out that the last ground boy is up here on the very top of Rochester. So now let's talk about play mode. Play mode is when the editor enters gameplay and the project runs. So basically, it's, as I said before, it is what your player will see. And you can enter play mode by pressing this little button up here in the toolbar that is the play icon. And it should take a bit to load, which is normal. And then you'll see the game view. In play mode, we can actually switch back to scene view, and we can go around our world and we'll see that the ground boy will start dancing. And the ground boy wasn't dancing before because we weren't simulating gameplay. And so the code to make him dance wasn't running. But since we're in play mode, now all of that is running, and yeah, the ground boy is going to dance. And you can exit play mode by pressing the square icon in the toolbar. So a really useful feature of play mode is that you can actually edit game objects while play mode is on, and being able to manipulate objects during gameplay is very useful for debugging. However, please note that any of your changes made to game objects when you're in play mode won't be retained. They'll all, right as you exit play mode, all the changes you made will be reverted back to before you entered play mode. So for example, let's say we were editing this scene in play mode. And we decided that we actually don't want this ground boy up here. We're going to move him somewhere else. So we can move him, let's say closer to the other ground boy. And I just realized that this one's much bigger than the other one. But right as we exit play mode, he's gone. And he's back right where he originally was. So just remember that any changes you make during play mode won't be saved. It can be useful for debugging, but just make sure that any changes you want to make that you're just keeping noted down. So there's also this setting called the play mode tint, and this tints the screen any color you like when play mode is active. And this is just designed to remind you that you are in play mode. And you can reach the setting by heading to Edit, then Preferences, then Colors right here, and you can select Play Mode Tint. I'm just going to make mine like slightly pinkish red. And now you see when I click play mode, it gives my entire screen this red tint. And basically it just reminds me that any changes I'm making, like if I were to delete this ground boy, that will not be saved after I exit play mode. So it's just a nice little reminder that we like to recommend here at Studio X. So let's talk about prefabs, and this is pretty much the quintessential feature of Unity, is prefabs. And these are saved game objects intended for reuse. So they have pre-configured components and can be reused anywhere in your project, and it's really just intended to save you time. And a really important fact is that editing the prefab changes all the instances of that prefab in use. This is useful because, for example, let's say you are making a zombie survival game. So you make a zombie 3D model and you've put the zombie in your scene, but you need more of them. What are you going to do? Just survive one zombie? So you make an army of zombies and you copy and paste them until you have as many as you want. Then you realize that you actually need to give the zombies a component that allows them to walk towards the player. Now, instead of manually adding the new component to every single zombie you made, let's say, you had 20 zombies in your scene and you wanted to give this component to all 20 of them, you'd have to individually click each one and give it to them. But instead of doing that, if you instead just had a zombie prefab, you could make one change that could apply to all the rest of them. So the lesson is, make a prefab whenever you want to use something more than once. So what we're going to do is we're going to practice with prefabs, and we're going to add a Fox prefab, which we are going to find in the project window. So the Fox prefab is in Eastman Quad, Prefabs, Characters, Fox, Prefabs, and Fox. Now, if that's a bit too complicated for you, I know that's a very long path, you can always just look up Fox in the project window and just enter this folder called Fox and then into the prefabs folder, and you will find a Fox there. Now what we're going to do is we're going to add this Fox into our scene, and we can do that in two different ways. We can either drag the Fox right into our hierarchy, and make sure that you're dragging it into an empty space and not into one of these existing game objects. And if you don't have any empty space, you can always close these folders. So you can drag it in there, and then you'll see that the Fox has entered our scene. However, another way you can do it is you can drag the Fox directly into the scene. And this also allows you to place the Fox wherever you would like to. So I'm just going to place the Fox right there. So now we are going to change the Fox's position, rotation, and scale. So we can do this by selecting the fox, either by clicking on it in the scene view or clicking on it in the hierarchy. And we can go over here to this little window. These are our different tools that we have. So right now we're in the move tool. So we can drag these arrows to move the fox in any of the 3 different axes. We can also select these little squares here and move the fox sort of more freely. And you can do that with any of the 3 axes. So another thing we can do is change the scale. Or I guess I should go over rotation first, since it's up next. So rotation is right under the move tool, right here. And you can just click and drag any of these circles and move your mouse from side to side. So you don't have to follow the circle. That actually won't work. You have to move it from side to side, left to right. And just like with the position or with the move tool, you can rotate in any of the 3 axes. And next is scale. So again, make sure you're selecting the fox, and you can scale the fox in any of the 3 axes, just like the other 2 tools previously mentioned. And you can make the fox look pretty weird with this if you don't do it all at the same time. Which you can do. You can uniformly scale the fox so that it doesn't look too weird. And you can do this by pressing the middle box, the gray box, and dragging left to right. And this will uniformly scale the fox on all 3 axes. And the only other thing that we have left to do with this fox right now is we can make a new prefab. So let's say we wanted like a really big fox. So we make a really big fox, and we want to be able to make more of these big foxes all around our campus here. So what we can do is we can actually make a new prefab of the fox. We can do this by clicking on the fox game object in the hierarchy window and dragging it into our project window. And because this is already a prefab, it's going to ask if we want to make a prefab variant or original prefab. We're going to make a prefab variant, and it's going to be called Fox Variant. And now we can place as many of these bigger foxes around as we want. And now I'm just going to delete them because I only want the one left. Also, for those tools I was mentioning earlier, the move, rotate, and scale tool, those have keybinds. The move tool is W, the rotate tool is E, and the scale tool is R. However, using the user interface right here is perfectly fine as well. So, the camera. Let's talk about the camera. Remember how there are 2 view modes, scene view and game view? Well, the angle that the game view uses is determined by the camera game object in your hierarchy, which is listed as the main camera. And the camera is a game object that renders your scene. It's what your user will see, and it behaves similarly to a camera in the real world. And we can find, as I mentioned earlier, in the hierarchy, our main camera game object. And we can actually enable, by clicking on this little strip of buttons here, we can click the camera icon, and it will bring up a preview of what our camera is currently depicting. So right now we see that the camera is showing this view. And right there I enabled something called the Gizmos button. And Gizmos lets you see some more detailed information about your scene. For example, it's showing me that there's a light here with this light icon. If I didn't have the gizmos on, it wouldn't have shown me that. And it also shows me where my camera is. And additionally, when I have the camera selected, it shows the field of view that the camera is showing. So these little white lines show the field of view. So the Gizmos tab is very useful if you want to see some extra information about your scene like that. So now that we have our camera selected, we're going to actually adjust the camera. And we're going to adjust it so that it frames behind the quad fox. So we're going to, locate the main camera. We already found it earlier, but in case you didn't, it's right up here. And you can focus on it by double-clicking on it. This will snap your scene to the position of the main camera. So if I fly away and then double-click on the main camera, it'll bring me back right to it. And then we're going to adjust its position. So just like a regular game object, like the fox, where we can move the position and other factors like rotation and scale, we can do the exact same for the main camera. For any object in your hierarchy, actually, you can do that as long as it has a transform component. So now we can adjust the camera and we'll see that as we're moving it, what it's showing, changes. And there we go. And we'll move it to behind the fox, rotate it again. Okay. And I'm going to take a look. And you can also manually edit the position, rotation, and scale of your game object in the transform component in the inspector window. So for example, I'm going to make all of this 0, 0, 0 for rotation. And we'll see that that's pretty much exactly how I wanted it to be. So now it's showing the fox, and we are ready to go for the next step. Oh, actually, first, press play to run your game. And we will see that indeed the game will display what we just moved the camera to. And you'll also see that the fox, just like the Ground Boys, is animated. So now we're going to do some custom scripting. Which tells game objects how to behave, as I mentioned earlier. And these are written in C#, and so we can also create public variables that are editable in the Unity editor. So why do we need scripting? So right now, for example, we have a 3D space where our camera is looking at our character, but we don't have any way to interact with the world during play mode. We're essentially, watching a movie, I guess. And if we want to be able to interact with the game during play mode, we need scripting. So let's try to make it so that our fox will be our player character. So we already positioned the camera behind the fox, but now what we're going to do is we're going to add a component to our camera that makes it so it follows the fox around. And this is going to be done with a component called Follow Player that we've provided for you in this project. Now you'll see a few things with the Follow Player. It has two public variables for us to edit. One is called player, one is called offset. And for this script to work, we need to supply this player game object to this script so that the script knows what game object to follow. In this case, we want it to follow our fox. So we can do two different ways to get the fox into the follow player script. We can either drag the fox from the hierarchy into the player script, or we can click this little circle here and we can select it from a search bar and we can find fox. But usually dragging in does the trick. So now let's see if it works. Does our camera follow the fox? All right, so we'll wait until the fox starts moving. Oh! And we will see that yes, the camera is following the fox. So that component is working correctly. But we still can't control the fox yet. So now we need a component on the fox. But first, I'm going to go over this offset variable. Let's, just for the sake of showing, set all these numbers to 0 and re-enter play mode. So we'll see that the camera is now not really in a spot that we'd like it to be. And this value is pretty hard to edit while you're not in play mode because it doesn't show in the scene view. So what you can do is manually edit these values. So, and one of those ways is you can directly type the number you want, but you can also click on the variable name and drag from left to right. And then we'll be able to find an offset that we like. However, as we know, once we exit play mode, none of the changes we just made will be saved. So you can do two things to be able to save these values. One is that you can click on the 3 dots on the script and copy the component. And then exit play mode. Once again, click on the 3 dots on the script and then press paste component values. And we will see that our values have come back. The other option is, instead of doing that, you can just write down the values or remember them and then put them back in after you leave play mode. All right, so now let's get to making the player move, making our fox move. So the first thing we're going to do is disable the animator component because we don't want this animation to be interfering with our gameplay. And the next thing is to add the player controller script. And now let's give it a test and let's see if our fox will move. All right, so you can press the WAS and D keys to move the fox. And currently, I'm pressing W and S, but nothing's happening. But when I press A, I go left, and press D, I go right. So it seems that something is missing here. Let's check the script. Now, the default script editor for Unity should be Visual Studio or Visual Studio Code. However, I'm using a different application, but it should look very similar to whatever you are using. So, here's our script, and we'll see that the code for moving left and right is right here, but the code for moving forward and backward seems to be missing. And so we can actually fix this. So first of all, let's see, horizontal input. Okay, so horizontal input is defined up here and declared up here. And so since we need something for vertical input instead, we should add a variable called vertical input. And then you'll see that my editor immediately auto-completed it for me, but vertical input equals to input.getAxis vertical. And then we can perform the same calculations that we would for up here. Now, except for one or two very important differences. Here, when we're translating the transform, we're going to use vertical input instead of horizontal input, and for instead of vector3.right, we're going to use vector3.forward. And my editor incorrectly completed that for me. We're going to do vector3.forward. Then you can press Ctrl S to save the script, and Unity should pop up saying that it is refreshing and recompiling everything. All right, so now let's try again and see if up and down movement works. All right, so A, D for left, right, and W and S for up, down. Perfect. This is exactly what we wanted. All right, so just a tip here, remember to save your project just in case, as I said before, something crashes, your computer dies, etc., etc. Just make sure that you are saving your project. So this is a good time. You can just press Ctrl S. You can also go to File, Save Project. So now what we're going to do is we're going to start to customize our project. And we can do this by finding and adding a free asset from the Unity Asset Store or another online marketplace. And you can actually automatically go to the Asset Store by clicking Window Asset Store. And then this should bring you to this page, to assetstore.unity.com. And what we do now, since we're working in a 3D space, we can click 3D. I'm going to go for props. And you can scroll down and find free assets in the little sidebar here. And you should be able to find, if swords are your thing, or if, food is your thing, you can, or cooking, I guess, you can try out some of these assets. They're completely free. Just remember to double check their licensing. And so if you're ever going to use these in a product, just remember that to stay true to whatever license agreement that they have dedicated that asset as. This one, for example, uses the standard Unity Asset Store EULA. And so you can go ahead and read through that and make sure that you're not going to get into any legal trouble using these assets for a product or any other sort of project. For me, I'm going to download these RPG fantasy weapons because I've always loved swords and things like that. And so I'm going to import this into my project, and this will bring up this package, or this window, I mean. So actually before that, this button will be different. It will say add to my assets because I already have this asset. It just says open in Unity, but then the process should be the same. It'll have you click open, and then Unity should automatically open to that. If it doesn't, then you can always search for in your assets for that package. And I looked up RPG, and it was the first thing that came up. So I'm going to import it into my project. And this lets you decide what you want to keep. For example, you may not want to keep the example scenes or different things like that. I just want the actual prefabs and materials and models. So I'm going to click import. All right, now it says it's in my project. So let's look in our project window, go back to the main assets folder. And we'll scroll down a bit and we'll find that there is a new folder called Low Poly RPG, weapons _ light. And this is exactly what I wanted. So whatever, this folder will obviously be different depending on what asset you download. But you should be able to find, it should be either the creator's name or the name of the package. So you should be able to find a folder like that. And then I'm going to want to directly go to prefabs, and oh no, all of these are completely pink and they don't look like what they're supposed to. They're supposed to look like this, but they show up completely pink. Even if I drag them into my scene, they're just completely pink. Now don't fret, this is normal and is going to be just a regular part of interacting with Unity assets. What this means is that these materials weren't designed for whatever render pipeline I'm currently on. And there are a few different render pipelines in Unity. I'm not going to go over that right now. You can look them up. But if you want to be able to use these materials in your project, there's a few different ways. So you can click Window, Rendering, and then Render Pipeline Converter. And you can select Material Upgrade and then select Convert Assets or Initialize Convert. However, there is sometimes a simpler way than doing this. You can actually select your materials. And you can do that either by, pressing Control A to select everything in the folder, or you can hold Shift and select them, or hold Control and select them. And then you're gonna want to go to Edit, Rendering, Materials, and then Convert Selected Built-in Materials to URP. And that is, of course, if you're using the Universal Render Pipeline. So we're going to press Proceed, and we'll see that, hey, they aren't pink anymore. And if we try to drag one of our prefabs in, they still show up pink in the folder, in the project window. But once I drag them into the scene, they have full color and they're ready to go. So here is a tip. As I mentioned earlier, credit your sources. Make sure you read and understand the license of any asset you use from the Unity Asset Store and credit accordingly when applicable. All right, so now we're going to talk about another very, very, very important aspect to Unity, which is the physics engine. And currently, there's nothing really in our scene that's using physics. The Fox is moving around, but we're doing that by directly manipulating its transform component rather than, using some sort of physics way to do it. But if we wanted to give the Fox some physics, we would need something called a rigid body. And so a rigid body is a component that allows any object to be affected by physics. So for example, you can see in this animated video here that the ball on the left has a rigid body component and the ball on the right does not. Or if it does, then gravity is not enabled. So we're going to give our Fox some physics. We're going to add a rigid body component to the quad Fox and we're going to test it out and see if it works. And so we can do this just like we did before with the other scripts. We're going to click Add Component, then we're going to look up rigid body. And we're not going to want to choose rigid body 2D because we're working in a 3D space. Okay, so now that we have the rigid body, let's head to test the game. We have gravity enabled. Looks like we're all good to go, so let's see if it works. And it works, and our Fox is falling right through the map, and we can see it falling. I'm not going to be able to catch up with it, but it fell right through the map, so it definitely has gravity, but one thing it doesn't have is collisions. So we can't just be set with a rigid body. We also need something called a collider. And colliders are components that detect collisions between each other. And so there are different types of colliders. You can see in the image provided here. There are box colliders, sphere colliders, capsule colliders, and also mesh colliders, which are colliders that directly take on the form of the model. And these can be really useful for different types of objects that are hard to, make a box or a sphere or a capsule collider for. But they also are more complex and will contribute to how hard your project is to run. So in general, we suggest using box colliders and other simple colliders. So we're going to stop our Fox from falling through the ground. And to do this, we're going to add a box collider component to the Fox. And we can do this again, just as always, by clicking Add Component, Collider, and clicking Box Collider. And we'll see that if you have gizmos enabled, you will see a box show up. If you don't, then it won't show up. But if you don't have gizmos enabled, you can always see the box by clicking the Edit Collider button here, which is what we're going to need to use anyway. And we will see that the box doesn't really fit the Fox at all. And so we can actually edit the collider by dragging these tiny green squares until it more or less takes the shape of the Fox. And if this seems a little, too hard to do, the boxes are really hard to see. There are simpler ways to add colliders to your object. For example, with this Fox, this parent game object actually doesn't have any information about the the model, the 3D model of the fox. This is the game object that has the information about the fox. So if we add a box collider to this component, it will automatically cover the fox. You don't need to do any editing. But in cases where you do, still useful to know that you can drag these boxes to edit the collider. All right. So we have a rigid body and a box collider. Now let's test the project again. All right, so our fox isn't falling through the floor, which is a good sign. And we can actually still move around. And yeah, so it's detecting the floor and, it's bouncing around a little bit now that it has physics. So this is perfect. This is exactly what we wanted. So now what we're going to do is we're going to knock down some boxes just to show off physics in Unity. And so we're going to make a tower of boxes and we're going to duplicate them and we're going to knock those boxes down with the fox. So you can do this by right-clicking an empty space in your hierarchy, clicking 3D Object, and clicking Cube. And this will put a cube into your project. And you can always reset its position manually and move it around and whatnot, just as usual. And now we have this one cube, but that's not very interesting. We want to make a whole tower of cubes. So what we can do is first acknowledge that this cube has a box collider already attached to it. We don't need to do any editing. We don't need to add it. It's already there, but it doesn't have a rigid body. So we'll give it a rigid body. Now it has physics. And now we can start duplicating it. And you can do this by selecting the cube in the hierarchy and pressing Ctrl D. And that will make a new one at the exact same spot as the old one. And I'm just going to make a kind of tower here. All right. Now, let's see if we can knock them down. All right. So, there they are. And there we go. So, we'll see that the fox collided with all these boxes and knocked them down. Or some of them are still standing. Not anymore. Okay. Last thing I'm going to go over is we have included a character controller prefab called the Super Character Controller. And this is a free asset that's readily available on the internet. But it is a basically a very well-made first-person and third-person controller. And so we're going to just add it to our scene. And since if we look in its hierarchy, it has its own camera, we're going to do something called disabling a game object, which we can do by clicking on the game object and then clicking this little check mark in the inspector. And we'll see that the text goes gray and that camera is no longer being used in the scene. And we'll see. Yeah, now we can switch it to the other camera. And I'm going to also disable the player controller just so that the fox doesn't start moving around while I'm moving with the first person controller. And we've actually also included a component called it's called, give me one moment, primitive placer. It's called primitive placer. And we just need to give it the camera, which is this game object right there. And now we can test out this fancy first-person controller in our Unity project. All right, so, so you can press WASD to move around. You can move the mouse to move your view. You can even hold shift to start running. Just know that your stamina will run out eventually. And the primitive placer component allows you to press P, O, or C, and it will create a new random color object, either a plane, a cube, or a sphere. And you can just go around, run around the map, and press and add as many of these as you want. And they also have colliders, so you can jump on them. They won't have physics, though. And because planes are 2D objects, when you try to look up at them, you'll see that they disappear, because they can only be viewed in one dimension, or in, I guess, 2 dimensions, but yeah. All right, and that's about it for the Unity project. So I'm just going to talk really quickly about future Unity work. So debugging is a journey. Find joy in those small successes. And also know that you are not alone. You can join our Studio X Discord to get help. You can request a consultation at our website. We'll have office hours for those of you in some of the classes that we offer office hours for. We also have these workshop recordings on YouTube, and you can also feel free to Google anything about Unity or a bug you're having. There's a lot of stuff on Stack Overflow and the Unity forum, so go crazy and go start creating whatever you want to make. Thank you.